Welcome to Strength of Material Lectures by Civil Thinking, and in this class we are going to understand the theory of pure bending equation. Okay, we will derive the equation. As you know, the theory of pure bending equation is something like this: E by R is equal to sigma by Y is equal to M by I. Okay, this is the equation of pure bending where E is modulus of elasticity, R is the radius of gyration, Y is the distance of layer from neutral axis, M is the moment or moment of resistance, and I is the moment of inertia. Okay, basically area moment of inertia. Now you will understand everything. Okay, now we are going to see where this equation comes from. Okay, now in today's lecture we will only see this part, and then this is equal to m divided by I. We will see that in another class. Now first we will see this. Now let me consider a beam. Okay, suppose this is a beam. Okay, now it will bend, right? We know that assumption of theory of pure bending is what? The assumption is it will bend into circular shape. Okay, it will bend something like this, right? I'm assuming this beam will bend like this, right? Okay, and this is a part of a big circle. Okay, this is a circular arc. Okay, this is the reason I draw whole of the circle here. Okay, actually the beam is only this part, right? And it will bend into a circular arc, right? Now let me assume, let us say this is the neutral axis. Okay, this is the center. Suppose this is neutral axis. Okay, now again, if you don't know about the neutral axis, please watch my video lecture on neutral axis. You will understand. Okay, now if this is the neutral axis, now here it is not bent, right? When you apply a load on it, it will bend something like this, right? It will bend something like this. So I'm also drawing the neutral axis here. The neutral axis will bend too, right? But keep in mind, one thing is very important: length of neutral axis does not change. Okay, does not change. This is really important. What does that mean? It means no strain in neutral axis, right? Why? Because what is strain? Strain is denoted by epsilon. It is change in length delta L divided by original length. When the length of neutral axis does not change, there will be no strain. Now when there will be no strain, there will be no stress, or basically no bending stress, right? That means in the neutral axis Na, it will bend, but the length will not change. Now let's consider another line. Okay, suppose I'm considering a fiber in this beam. Suppose this is the fiber. Okay, excuse my handwriting. You can assume this to be perfectly straight. Let's call this as PQ. Okay, and it is at a distance of y from the neutral axis. Okay, now this will bend too. Now I have already told you when this is going to bend, right? Let me first draw it. So let me say this is PQ. Okay, this is P and this is Q, right? Now PQ, as you can see in this bend part, PQ is in tension, okay? This is tension zone, right? All of this below the neutral axis, it is tension zone, and above the neutral axis, it is compression zone, right? Again, if you don't know why it is tension zone and why it's compression zone, please watch my video lecture on it. It's very simple. Basically, when you bend this, okay, let me draw something here. Suppose we have a beam here, okay. When you apply a load on it, when you apply this load, it will bend like this, right? It is going to bend something like this, and of course it is going to be a part of a circle, right? Because that is the assumption. In reality, it is not part of the circle, but this is just an assumption, okay. Now when it will bend, okay, okay, now when it will bend, suppose this is the neutral axis, okay, the neutral axis will bend too, okay. Now when you are going to bend, you can see here the above part is in compression, and this part, okay, this part, it is in tension, right? This is in tension and this is in compression. This is the reason this region is called as tension zone and this is called as compression zone, okay. Anyway, it was not the topic. Okay, let me go back to the topic now. Okay, now it is at a distance of y, okay. Let the radius, let the center of this circle be here, okay, and from here to here is r, okay. From the center to the neutral axis is r radius, okay. Now if I erase all of this here, now you say, let me assume the length of this beam is, of this part of the beam is L, okay. Now what is the length of neutral axis? Length of neutral axis is equal to L, okay. Let me call this as figure 1, okay, and this one is figure 2. Length is L, but in what? Figure 1, right? As you can see in the figure 1. Now what is the length of neutral axis in figure 2? Now here it is an arc, okay. Now the length, let me assume like this, let me connect it like this and here, okay. Now this is radius r, okay. I will remove this part. This is radius r. Let the angle subtended here is theta. Now we know length of an arc is what? R theta, okay. Length of this neutral axis is r theta, right? In figure 2, right? It means L is r theta, right? Because here the length of neutral axis is L and here the length of neutral axis is r theta, right? It means the L is r theta. Now let me talk about PQ layer, which is in the tension zone. Now let me write length of PQ is equal to L again, right? But in figure 1, right? Now length of PQ is how much in figure 2? Can you say in this figure what is the length? How you are going to find the length? Now see, we know from here to here is r, right? R. Now if you look at PQ, from here center to here, the length is not r but the length is r plus y, right? So length of the PQ, because PQ here is an arc and length of the arc is radius multiplied by the angle subtended. So here the length is radius is r plus y, right? I'm talking about PQ. It is r plus y is the radius and theta is the angle, right? Now see, in PQ the length is L and the length of PQ in figure 2 is r plus y theta, right? Now what is the, now see, you can see this PQ is in tension zone, okay. This PQ is in tension zone. The length in the tension zone increases, right? Suppose if you have something like this and it will mainly, it bends like this. Now this is in tension, this is compression. You can see in the tension zone the length has increased, right? See, if this is the length like this, you can see this part and this part has increased, and in the compression zone the length decreases. Okay, anyways, we know the length of PQ has increased. Now how much is the increase in length? Increase in length of PQ, how much is it? Can we say this length in the figure 2 minus this length of the PQ, the length of PQ in figure 2 minus the length of PQ in figure 1, it will give us an increase, right? So it will be r plus y theta minus, what is the length of PQ in figure 1? It is L, right? PQ. But we know L is r theta. So I can also write L is equal to r theta, okay, in figure 1, right? Minus L, right? But in place of L, I can write r theta, okay? Now r plus y theta, it is r theta plus y theta minus r theta, okay? Now r theta cancels out. We are left with r theta. We are left with y theta, right? Now this is the increase. Now what is the strain? Strain in PQ. Strain is change in length. If it is a decrease or increase, whatever, change in length, delta L. Now increase in length of PQ, let me call this as delta L, okay? Increase in length divided by original length, L naught, okay? Now delta L is what? Y theta, right? So it is going to be y theta divided by, what is the original length of PQ? R theta, right? Now theta and theta cancel, we are left with y by r. So the strain in PQ is y divided by r, right? Now let's talk about stress, the bending stress. Bending stress. Now you know stress is equal to Young's modulus of elasticity multiplied by the strain, right? Now here we can apply sigma is equal to E multiplied by y by r, okay? Now if I rearrange this, we are getting sigma by y is equal to E by r, right? Sigma by y is equal to E by r. So we get sigma by y is equal to E by r. We have proved this, okay? In the next class I am going to prove this. Now again, if you need the PDF of this video lecture, it is in the description. The link is in the description. You can download it from there. And again, if you need tutoring in strength of materials, mechanics of materials, okay, you can also contact me for that, okay? And I think that's it for today. See you in the next class. Thank you.